Hello, and welcome to another episode of the Daily Bolt with your host, Dr. Jeff Tilley. Today's topic, Dorian's competing forces and green and red blobs. Sit back and relax and enjoy today's episode of the Daily Bolt. So, this is a weird title because this is kind of a hodgepodge podcast. Dorian briefly passed over Cape Hatteras, North Carolina on the Outer Banks this morning. It took roughly about 2 hours for Dorian's eye to cross Cape Hatteras, and Dorian has now continued off in a northeasterly direction away from the remaining Outer Banks and the U.S. coastline. So it will be continuing over the next day or so well south of the U.S. coast. There will be some storm surge flooding still for a while in the Pamlico Sound area and land areas that border it in North Carolina, probably for the rest of the day, maybe into this evening. And then it will be slowly subsiding, with maybe a small amount of storm surge flooding, maybe a foot, maybe two, if it really gets closer than expected, to the southern coast of Massachusetts, the Cape Cod area, etc. Dorian's next main target on its current trajectory, which is now fairly well determined by the course of the wave motions in the mid-latitude westerlies, will be Nova Scotia. And it looks like Dorian will not just graze the coast of Nova Scotia, it's going to go right over the entire island of Nova Scotia, probably giving areas of Nova Scotia that haven't seen hurricane force winds for a while an experience that they won't forget soon. Dorian's winds will still be close to hurricane force. It may not be a hurricane anymore at that time. It may have made a transition to what we call an extratropical low, or basically for what most of the United States refers to simply as a low pressure system. But it will have very strong winds nonetheless, because Dorian continues to move very close to the Gulf Stream, and the warm waters of the Gulf Stream continue to provide fuel for the hurricane to sustain itself, even working against the effects of the vertical shear of the wind that we've talked about before with Dorian and other hurricanes, to weaken the hurricane. So we have these competing effects going on. We have gradually increasing vertical wind shear the farther north that Dorian goes into the westerlies, and we still have warm enough water to fuel thunderstorms that can keep a significant part of the circulation going. And as a result, over the last day, Dorian has weakened some. Its maximum winds are about 90 miles an hour right now, making it basically a borderline Category 1, Category 2 hurricane. But it has only weakened very slowly over the last 2 days. It's lost maybe 20 miles per hour of wind speed from a border Category 2, Category 3 to now a borderline Category 1, Category 2 hurricane. And the weakening is expected to continue roughly at a similar rate. And given that the fact that Dorian is now accelerating, it's moving just under 18 miles per hour right now and continuing to accelerate, it's going to reach Nova Scotia still with some winds, at least wind gusts, at hurricane force, whether it is a hurricane or whether it is just a strong extratropical low. And after crossing over the entirety of Nova Scotia, it's going to head into the Gulf of St. Lawrence, which normally doesn't see hurricane activity or very strong winds of that nature very often, certainly not this time of year. It's more a wintertime phenomena, and potentially go over province of Newfoundland and Labrador, whether it goes through the strait between the two parts of that Canadian province or whether it goes over land. It's still going to be a strong low-pressure system and then head off into the far North Atlantic, where For all we know, its next target might be Greenland or Iceland. Regardless, the main threats of Dorian to the U.S. are diminishing throughout the day today. Basically, probably by this time tomorrow, there will be not much except for some enhanced coastal beach erosion and high swells along most of the U.S. coast. And we'll be looking to see how strong Dorian remains as it approaches Nova Scotia. So, Dorian's got these competing forces. 50, 60 years ago, we didn't know about all these possible impacts on hurricanes and about how they would interact together because we were still in our infancy in understanding hurricane circulation 60 years ago. We had some basic ideas, but a lot of theory that was developed in hurricanes came by obtaining data and trying to make it fit with what we understood about the physics of the atmosphere and the ocean. Astronomers are doing the very same thing, looking through very high-powered telescopes. There are several of these around the world in several different countries, and sometimes we don't really hear too much about them, and we don't pay that much attention to astronomy, except when we hear a report about some close call with an asteroid or a comet that would, if it hit the planet, decimate life as we know it, or some other catastrophe. But astronomers do a lot of work that's relatively quiet in the background. But this week, amid all the hubbub over Dorian, there have been a couple of interesting discoveries in astronomy involving what we can call blobs, for lack of any better term. The first one deals with a discovery that actually occurred 9 years ago. Astronomers were working with a gamma-ray space telescope called the Fermi telescope, and they discovered these two giant blobs of gas, very high-energy gas, that were centered on the core of the galaxy, but that extended above and below the plane of the galaxy. So if you took the galaxy and you put it on its side, you'd see these blobs, one above it and one below it. And there's actually a good picture online, which I will post on my Facebook page, to show you how these might look in terms of gamma rays and X-rays observed on the telescope. It's a good diagram. It doesn't have too much detail, but it does show a very telling picture. And for those of you who are wondering, well, what's a gamma ray? What's an X-ray? We need to talk just a little bit about the electromagnetic spectrum. The electromagnetic spectrum is all the energy that we call radiation. That includes light. That includes visible light, all wavelengths. It includes infrared light. That there are glasses that you can wear at night to see the infrared radiation. All of our bodies emit infrared radiation. Radio waves, microwaves, X-rays. You go to get to the doctor and get an X-ray. An X-ray is a type of electromagnetic radiation. We worry about ultraviolet energy in terms of sunburn. And the most high energy particles of all are gamma rays. Very, very, very small wavelengths, very high frequency, lots and lots of energy. And so by devising a telescope to look for the gamma rays, we saw a structure that you could never see with a regular visible optical telescope. And that's what that picture shows. And I'll post this picture on my Facebook page at the completion of recording this podcast. These are huge bubbles of gas, and they've emitted lots of radiation. Now, this week, what was discovered was the emission of even more high-energy particles that are called neutrinos. Neutrinos are particles that have almost no mass in the first place. And It only interacts with other particles versus very weak nuclear forces within the particle. And basically what that means is it almost never interacts with normal matter at all. They can actually pass through matter and not hardly even be noticed. If you get lots of neutrinos passing through matter, then you have a problem because of all the energy they contain. But the gamma rays can produce one particular type of energy. What produces the neutrinos is not always clear. It's not always certain, and this is where I'm tying this back to the end of the Dorian discussion. We really don't know everything about what produces neutrinos, and yet it was observed. And the scientists who observed it recently tried putting everything that they've been observing in the data together with existing theory, and they still don't really know, which means we need more data. Just like with hurricanes, 50, 60 years ago, we understood a few things about them, but we really needed more data to be able to better explain how they work and be able to better predict them. So we always need more data in science. And sometimes that data is something totally new, like the neutrinos and like images of this galaxy, NGC 6946, sometimes called the Fireworks Galaxy, that is 22.5 million light years away. This was a NASA X-ray telescope that picked up something unusual. Just very short-lived flashes of X-ray light that lasted only a few weeks. Normally, when we're looking at something that's 22.5 million light years away, if something occurs, the light signal often lasts for a significant period of time, not for a period of weeks. But these flashes of X-ray light occurred over just a period of a few weeks in a few different places. And there's an image from this telescope that I'm also going to place on the Facebook page. This is a color-enhanced picture that will show these X-ray flashes as green and blue. So it's kind of green or blue blobs. So astronomers this week have seen red, green, blue blobs, and all this is going on amid the hubbub of Dorian. But we don't know anything about what these X-ray light flashes are. There are some theories, but normally in previous instances where such small areas of X-ray energy have appeared, they've lasted for long enough periods of time, and so we have thought, okay, it relates to matter going into a neutron star or a black hole or something like that. This is something new. And so there are possible explanations, but we don't have really enough data yet to really definitively even pose a theory that really has some robustness to it. We've taken steps toward understanding, but we need more data. Just like we needed more data for hurricanes to be able to better understand how they operate. So that's some food for thought for today as Dorian departs. For the Daily Bolt, I'm Dr. Jeff Tilley. Have a good day, and God bless.